Components are like factories. A common mistake candidates make is saying the virtual DOM is faster than the real DOM. That's not accurate. You can't change props within a component. If you need to change a value, it should be state, not a prop. Welcome to our comprehensive guide on React interview questions. Today, we'll be diving deep into 20 commonly asked interview questions about React, covering everything from basic concepts to more nuanced topics that frequently come up in technical interviews. Let's start with a foundational question that often kicks off React interviews. What is React and what are its main features? This question is crucial because it tests your fundamental understanding of the library. React is a JavaScript library created by Facebook, now Meta, specifically designed for building user interfaces. What makes React special is its component-based architecture, where you break down your entire UI into small reusable pieces. Think of it like building with Lego blocks. Each component is a self-contained unit that you can use multiple times throughout your application. React also introduces the virtual DOM concept, which dramatically improves performance by minimizing actual DOM manipulations. The library follows unidirectional data flow, meaning data flows in one direction from parent to child components, making applications more predictable and easier to debug. React uses declarative programming, where you describe what the UI should look like for any given state rather than imperatively telling it how to change. JSX, a syntax extension, allows you to write HTML-like code directly in JavaScript, making components more readable. When answering this in an interview, emphasize React's massive ecosystem and community support, which sets it apart from other libraries. The second question that frequently appears is about the virtual DOM and how it works. This is a critical concept that distinguishes React from traditional DOM manipulation. The virtual DOM is essentially a JavaScript representation of the actual DOM tree kept in memory. When you make changes to your application state, React doesn't immediately update the browser's DOM. Instead, it creates a new virtual DOM tree representing the new state. React then performs a diffing algorithm comparing this new virtual DOM tree with the previous one to identify exactly what has changed. This process is called reconciliation. Once React knows the minimal set of changes needed, it updates only those specific parts of the real DOM. This is why React applications feel so fast and responsive. A common mistake candidates make is saying the virtual DOM is faster than the real DOM. That's not accurate. Manipulating the virtual DOM itself isn't necessarily faster, but by batching updates and making minimal changes to the real DOM, React achieves better performance. When explaining this in interviews, use analogies like comparing it to editing a blueprint before renovating a house rather than constantly tearing down and rebuilding walls. Question 3 explores JSX and why it's used in React. JSX stands for JavaScript XML, and understanding it is fundamental to working with React. JSX is a syntax extension that allows you to write HTML-like code within your JavaScript files. Under the hood, JSX gets transpiled by tools like Babel into regular JavaScript function calls. When you write a JSX element like a heading tag with Hello World, it gets converted to react.createElement calls. The beauty of JSX is that it makes your components much more intuitive and readable compared to writing createElement calls directly. You can embed JavaScript expressions using curly braces, making it powerful for dynamic content. JSX also provides better error messages and warnings during development, catching issues at compile time rather than runtime. A common misconception is that JSX is required for React. It's not. You can write React without JSX, but it would be much more verbose and harder to maintain. In interviews, emphasize that JSX is syntactic sugar that makes React development more pleasant and productive. Remember to mention that since JSX isn't valid JavaScript, it requires a build step to transform it into regular JavaScript that browsers can understand. The fourth question addresses the difference between React elements and React components, a distinction that many beginners confuse. A React element is a plain JavaScript object that describes what should appear on screen. It's immutable and represents the DOM at a specific point in time. Think of it as a snapshot or a blueprint. When you write JSX like a simple heading tag, you're creating a React element. On the other hand, a React component is a function or class that returns React elements. Components are like factories that produce elements. They're reusable, can accept inputs called props, and can maintain their own state. You can create a welcome component that takes a name prop and returns a customized greeting element. The key distinction is that elements are what components return, while components are the reusable building blocks of your application. In interviews, use the analogy of a cookie cutter component versus the actual cookie element. The cookie cutter can be used multiple times to create many cookies, just like a component can be used to create many elements. A common mistake is trying to modify elements directly. Remember, elements are immutable once created. Question 5 explores the differences between functional and class components, a topic that reveals your understanding of React's evolution. Functional components are the modern approach, written as simple JavaScript functions that return JSX. They're cleaner, more concise, and with the introduction of hooks, they can do everything class components can do. They have better performance due to less overhead and are easier to test because they're just functions. Class components, on the other hand, use ES6 class syntax and extend React.component. They were the only way to have state and lifecycle methods before hooks were introduced. Class components use this keyword extensively, which can lead to binding issues and confusion. While class components are now considered legacy, they're still fully supported and you'll encounter them in older code bases. In interviews, emphasize that functional components with hooks are the recommended approach for new development. They eliminate common issues like forgetting to bind methods and make it easier to share logic between components. However, acknowledge that understanding class components is still important for maintaining existing code. A tip for interviews: if asked to refactor a class component to functional, focus on converting state to useState and lifecycle methods to useEffect. The 6th question asks how to create a React component, testing your practical knowledge. There are two main approaches: functional components and class components. For functional components, you simply write a JavaScript function that returns JSX. You can use either function declarations or arrow functions, both work perfectly fine. The component name must start with a capital letter to distinguish it from HTML elements. For class components, you create a class that extends React.component and implement a render method that returns JSX. In modern React development, functional components are strongly preferred due to their simplicity and the power of hooks. When creating components, follow the single responsibility principle. Each component should do one thing well. Keep components small and focused, making them easier to test, maintain, and reuse. A common mistake in interviews is forgetting to import React when using JSX, though this is no longer required in React 17 and above with the new JSX transform. Another tip: when naming components, use descriptive names that clearly indicate their purpose, like user profile or navigation menu, rather than generic names like component1 or my component. Question 7 covers the rules of JSX, which are essential for writing valid React code. First, and most importantly, JSX expressions must return a single parent element. If you need multiple elements at the root level, wrap them in a div, React fragment, or use the shorthand fragment syntax. Second, use camel case for attributes. It's class name, not class, on click, not on click, and tab index, not tab index. This is because JSX is closer to JavaScript than HTML. Third, all tags must be closed, including self-closing tags like image and input, which must end with a / before the closing bracket. Fourth, JavaScript expressions go inside curly braces. This is how you embed dynamic values and expressions in your JSX. Boolean attributes work differently too. You can write disabled equals true or just disabled for true values. Comments in JSX must be wrapped in curly braces and use JavaScript comment syntax. A common interview mistake is forgetting that JSX is case-sensitive for component names. Lowercase names are treated as HTML elements, while uppercase names are treated as components. Remember to mention that JSX prevents injection attacks by escaping any values embedded in JSX before rendering them. The eighth question explores React fragments and when to use them. React fragment is a feature that lets you group multiple elements without adding extra nodes to the DOM. This is particularly useful when you need to return multiple elements from a component, but don't want to wrap them in a meaningless div that could break your CSS layout or create invalid HTML. You can use React.fragment with the full syntax or the shorthand empty tags syntax. The shorthand is more concise and widely used, but the full syntax is necessary when you need to provide a key prop, such as when mapping over an array. Fragments solve the common problem of table rows, where wrapping TD elements in a div would create invalid HTML. They're also useful for definition lists and any situation where adding a wrapper would interfere with CSS grid or flexbox layouts. In interviews, mention that fragments help keep the DOM clean and semantic. A common mistake is overusing divs as wrappers when fragments would be more appropriate. Remember that fragments can only accept the key attribute when using the full syntax, not the shorthand. This is particularly important when creating lists of fragment groups. Question 9 addresses conditional rendering in React, a fundamental pattern you'll use constantly. There are several approaches, each with its own use case. The ternary operator is perfect for simple either-or conditions, where you show one component or another based on a condition. The logical AND operator is ideal when you want to show something or nothing. If the condition is false, nothing renders. For more complex conditions, you can use if-else statements before the return statement, storing the result in a variable. You can also use immediately invoked function expressions within JSX for complex logic. Switch statements work well for multiple conditions based on a single value. In interviews, explain that choosing the right method depends on readability and complexity. Ternary operators are great for simple conditions, but can become unreadable when nested. Logical AND is clean, but watch out for falsy values like 0, which will render as 0 rather than nothing. A pro tip: extract complex conditional logic into separate functions or components to keep your render method clean. Common mistakes include forgetting that logical AND will render falsy values like 0 or empty strings and overcomplicating simple conditions with unnecessary if-else blocks. The 10th question covers rendering lists in React, a common task that has specific requirements. The primary method is using JavaScript's map function to transform an array of data into an array of React elements. The crucial requirement is providing a unique key prop for each item in the list. Keys help React identify which items have changed, been added, or been removed, enabling efficient updates to the DOM. Keys should be stable, predictable, and unique among siblings. Using the array index as a key is generally discouraged, especially if the list can be reordered or items can be added or removed, as this can cause issues with component state and animations. Instead, use unique IDs from your data when available. Keys don't get passed to components as props, they're used internally by React. In interviews, emphasize that keys are crucial for performance and correct behavior. A common mistake is using math.random for keys, which creates new keys on every render, defeating their purpose. Another mistake is forgetting that keys only need to be unique among siblings, not globally unique. When explaining this concept, mention that without proper keys, React might mix up component instances, leading to bugs with state, animations, and input fields. Question 11 explores props in React, the primary mechanism for passing data between components. Props, short for properties, are read-only inputs passed from parent components to their children. They can be any JavaScript value: strings, numbers, booleans, objects, arrays, functions, even other React elements. Props make components reusable and configurable like function parameters. Once a component receives props, it cannot modify them directly, they are immutable from the child's perspective. This unidirectional data flow makes React applications predictable and easier to debug. You can destructure props for cleaner code, provide default values using default props or default parameters and validate them using prop types or TypeScript. Props can also include callback functions, enabling child components to communicate with parents. In interviews, emphasize that props are the component's configuration, while state is its memory. A common mistake is trying to modify props directly. If you need to change a value, it should be state, not a prop. Another pitfall is passing too many props, which might indicate your component is doing too much and should be split. Remember to mention that all React components must act like pure functions with respect to their props. The 12th question addresses state in React, the mechanism that makes components dynamic and interactive. State is a built-in object that holds data that may change over the component's lifetime. When state changes, React automatically re-renders the component to reflect the new state. In functional components, we use the useState hook to add state. State is local and encapsulated. It's private to the component and fully controlled by it. Unlike props, which are passed down, state is managed within the component itself. State updates may be asynchronous, and React may batch multiple setState calls for performance. This is why you should use the functional form of setState when the new state depends on the previous state. State should be treated as immutable, never modify state directly, always create a new object or array. In interviews, explain that state represents any data that changes over time and affects what's rendered. Common mistakes include modifying state directly, like pushing to an array instead of creating a new one, and putting derived values in state instead of computing them during render. A key point to remember: only put in state values that, when changed, should trigger a re-render. Question 13 asks about the difference between props and state, a fundamental distinction in React. Props are external and controlled by whatever component renders the current component. They're like function parameters, passed in from outside and read-only within the component. State, on the other hand, is internal and controlled by the component itself. It's like the component's private memory that can change over time. Props flow down from parent to child, creating a unidirectional data flow, while state is local to the component where it's defined. You can't change props within a component, but you can change state using setState or stateSetter functions. Props are used to configure a component and pass data down the component tree, while state is used for data that changes over time within a component. In interviews, use analogies to make this clear. Props are like the arguments you pass to a function, while state is like variables declared inside the function. A common confusion is when to use props versus state. If a piece of data is passed from a parent, it's a prop. If it originates and changes within the component, it's state. Remember, props are for component configuration, state is for component memory. The 14th question covers event handling in React, which differs from traditional HTML event handling. React uses synthetic events, which are cross-browser wrappers around the browser's native events. This ensures consistent behavior across different browsers. Event handlers in React are written in camel case, like onClick instead of onClick. You pass a function reference as the event handler, not a string. The function receives a synthetic event object that has the same interface as native events, but works identically across all browsers. React event handlers are actually attached to the document root, not individual elements, using event delegation for better performance. This is transparent to developers, but good to understand. In interviews, mention that React's event system is more efficient than attaching listeners to individual DOM elements. Common mistakes include calling the function instead of passing a reference. Writing onClick with parentheses immediately invokes the function instead of waiting for the click. Another mistake is forgetting that event pooling was removed in React 17, so you no longer need to call event.persist for async operations. Always emphasize that React events are synthetic but behave just like native events in most cases. Question 15 addresses preventing default behavior in React events, a common requirement for form submissions and link clicks. In React, you cannot return false from an event handler to prevent default behavior like you can in HTML. Instead, you must explicitly call preventDefault on the event object. This is commonly used with form submissions to prevent the page from refreshing or with anchor tags to prevent navigation. The event object passed to your handler is a synthetic event that has all the standard event methods, including preventDefault and stop propagation. It's important to call preventDefault at the beginning of your handler if you need it, especially for form submissions, to ensure it takes effect before any async operations. In interviews, demonstrate understanding by explaining real-world use cases like handling form submission with AJAX instead of traditional page refresh or creating single-page application navigation. A common mistake is forgetting to call preventDefault and form submit handlers, causing unexpected page refreshes. Another pitfall is confusing preventDefault with stop propagation. PreventDefault stops the default action, while stop propagation stops the event from bubbling up the DOM tree. Remember to mention that unlike some other frameworks, React requires explicit prevention rather than implicit through return values. The 16th question explores passing parameters to event handlers, a common pattern that has multiple solutions. The most common approach is using an arrow function in the JSX, which creates a new function that calls your handler with the desired parameters. This is clean and readable but creates a new function on each render, which could impact performance in large lists. Another approach is using the bind method to pre-bind parameters, which also creates a new function but can be done outside the render method for better performance. You can also create a separate component that encapsulates the parameter, passing it as a prop. For optimal performance in large lists, consider using data attributes and accessing them through the event target. In interviews, discuss the trade-offs of each approach. Arrow functions are fine for most cases, but might cause unnecessary re-renders in child components that use React.memo. Mention that creating handler functions outside the render method or using use callback can optimize performance. A common mistake is forgetting that arrow functions in JSX create new function instances, potentially breaking shallow equality checks. Another pitfall is trying to pass the event object along with custom parameters. Remember, the event is always the last parameter when using bind.
Question 17 covers the useState hook, the most fundamental hook in React. useState allows you to add state to functional components. It takes an initial state value and returns an array with two elements, the current state value and a function to update it. The naming convention uses array destructuring with the state variable and a setup prefixed with set. The initial state can be a primitive value, object, or array, and can also be provided as a function for expensive computations that should only run once. When updating state, you can pass a new value directly or use the functional update form, which receives the previous state as an argument. The functional form is crucial when the new state depends on the previous state, especially in scenarios with potential state batching or closures. State updates trigger re-renders, but React may batch multiple updates for performance. In interviews, emphasize that useState replaces this.state and this.setState from class components. Common mistakes include directly mutating state objects or arrays instead of creating new ones, and not using the functional update form when needed. Remember that unlike class component state, useState doesn't merge update automatically. You need to spread previous state when updating objects.
The 18th question distinguishes between controlled and uncontrolled components, particularly important for form handling. Controlled components have their form data handled by ReactState. The input's value is controlled by React, and every state change triggers a re-render. You explicitly handle every change with an onChange handler, giving you full control over the input's value. This approach makes it easy to validate input, format values, or conditionally disable form submission. Uncontrolled components, conversely, let the DOM handle the form data. You use refs to access values when needed, typically on form submission. This is closer to traditional HTML form handling. Uncontrolled components can be simpler for basic forms and might perform better with large forms since they don't trigger re-renders on every keystroke. In interviews, explain that controlled components are generally preferred because they follow React's declarative paradigm and make testing easier. However, uncontrolled components have valid use cases, like integrating with non-React libraries or optimizing performance for large forms. Common mistakes include mixing controlled and uncontrolled patterns in the same form and forgetting to provide an on-change handler for controlled inputs, which makes them read-only.
Question 19 explores Create React App, the official tool for bootstrapping React applications. Create React App, often abbreviated SCRA, provides a modern build setup with zero configuration. It includes pre-configured Webpack for bundling, Babel for transpiling modern JavaScript and JSX, ESLint for code linting, and Jest for testing. The development server features hot module reloading, so changes appear instantly without losing application state. CRA handles optimization for production builds, including code splitting, minification, and cache busting. It supports modern JavaScript features, CSS modules, Sass, and even progressive web app features out of the box. Environment variables are supported for different deployment environments. The tool provides several NPM scripts: start for development, build for production, test for running tests, and eject for taking full control of the configuration, though ejecting is irreversible and rarely necessary. In interviews, mention that CRA abstracts away complex build configuration, letting developers focus on writing code. However, acknowledge its limitations. It's opinionated and might include features you don't need. For complex requirements, alternatives like Vite or Next.js might be more suitable. A common misconception is that CRA is required for React development. It's just one of many ways to set up a React project.
The final question addresses the difference between React and ReactDOM, two separate packages that work together. React is the code library that defines components, elements, props, state, and the component lifecycle. It's platform agnostic, meaning it contains the logic for components but not the rendering logic. This separation allows React's core concepts to be used for different rendering targets like React Native for mobile apps or React 3 Fiber for 3D graphics. ReactDOM, on the other hand, provides DOM-specific methods. It's the bridge between React and the web browser's DOM. ReactDOM includes methods like createRoot for creating a root container, render for mounting components to the DOM, and utilities for working with DOM elements. This separation follows the principle of separation of concerns. React handles the component logic, while ReactDOM handles the rendering to the browser. In interviews, explain that this architecture makes React flexible and extensible to different platforms. When you import React, you're getting the component creation tools. When you import React DOM, you're getting the tools to render those components to a web page. A common interview follow-up is asking about other renderers like React Native or React Test Renderer, which demonstrate the power of this separation. Thank you for joining me on this comprehensive journey through React interview questions. Remember, understanding these concepts deeply and being able to explain them clearly will set you apart in your interviews. Keep practicing, building projects, and exploring React's ecosystem. Good luck with your interviews.